We will now reprise the style of the morning session with 3 presentations and a panel discussion and a little Q&A, something like what we did with the data on the fly inside the corporation. And the session may also in some ways address issues we had brought up inside the surveillance panel this morning, because what our speakers will address, each from their respective perspectives, is the way in which we're looking at the implications of living in a world with rich, deep, continuously interacting data sets of all sorts, along with highly empowered individuals, hopefully highly empowered individuals, and what those implications might mean for both data scientists and society at large. I'm going to get out of the way and let Joe talk, and then we'll hear from Kevin Coy at the Geospatial Innovation Facility and Michael Conover at LinkedIn. Then I'll come back and join them in conversation. Joe.
Cool. Thanks, Quinn. Can you guys hear me good? All right, excellent. I am not David Soloff. I think he was originally on the schedule as my co-founder at Premise. He couldn't be here for travel-related physical limitations due to, well, there's only one of them. I started a company called Premise. I gave a talk this morning. This talk hopefully will have nothing to do with that talk, so you guys are don't worry. I wanted to start with a bit of like a palate cleanser from actually some graduate game theory. I know we've been talking about like data and economics and social action and all that stuff all day, so I feel like game theory is a good clarifier, right? In particular, I personally like in my own line of work, I've been thinking a lot about this notion of like hyperlocal economic mapping and how that can impact local economic institutions. I've also been thinking a lot about kind of gamification. How do you coerce people to take mass action that may be socially beneficial, but they don't quite see the direct utility. So this paper kind of, I think, is going to set some of the tone for this talk. It's by Michelle Piccione and R.L. Rubinstein at NYU. And it's kind of an interesting take on it's kind of, there's this kind of open question of we know this, mathematically we know that equilibria of competitive economies are somehow Pareto efficient. You have these kind of nice mathematical results that are supposed to kind of feel good. But the question is inherently can you say anything about the inherent morality or social justice at a lower level? The answer is kind of course no, but this is a cute example of why. So we have a 3-item economy. It's ramen, it's pork buns, and it's fried chicken. It's this is the mission economy. There's the world consists of agents. There are people, we're just call them agents, and each agent has a set of preferences over those items, right? So in particular, this guy prefers ramen to pork buns to fried chicken. This one prefers ramen to fried chicken, doesn't like pork buns quite as much, et cetera, right? So they have these kind of explicitly stated preferences. The agents are going to participate in a competitive market. We'll define the dynamics of that in a second, but they're going to, they're able to interact. And they're also going to have an initial endowment. They start with at least one of the items, right? And what happens is the dynamics of the market, what can happen is the agents can engage in trade according to some set of rules, assuming that it meets some set of criteria. So what types of mechanisms might we want to consider for this, right? Well, the kind of the Econ 101 economy, right, is agents will exchange their goods whenever they both benefit from the exchange. So if you have what I want and I have what you want, we're going to trade, and so we're both going to be better off. This is kind of the sort of the foundational why gains due to and why capitalism is good, like all this sort of stuff. This is the I'm gonna call this the Care Bear economy. So what I really like about the Piccioni and Rubinstein paper is there's actually another set of rules. There's another set of rules that they call the jungle economy. And in the jungle economy, there's a secondary bit of information, which is the strength of the agent. So some agents are stronger than others naturally. And the exchange rule is whenever a stronger agent encounters a weaker agent, and the weaker agent has something the stronger agent wants, the stronger agent can just compel the trade, right? So the weaker agent may be worse off. The stronger agent will be better off. But it's sort of like it's rule by force, right? I can take what you have. So a couple of mathematical bits that we need. One is these economies, like you trade and trade and trade. Eventually, hopefully you reach some kind of equilibrium. There's this definition of a pretty efficient equilibrium where nobody can be made better off without somebody else being made worse off. This is you kind of reach this point in the exchange economy, and nobody wants to trade anymore because they're all pretty happy with what they have. So this is, by the way, this is all riffing off of Cosmo Shalisi. Don't read his blog; it's phenomenal. So essentially, assume some obviously false conditions about what people want, and still more obvious falsehoods about the institutions that they have. Let people trade. If they want to, and only if they want to, then the market will come to equilibrium when nobody wants to trade anymore, right? And the equilibrium is a situation where nobody can be made better off without somebody else being made worse off, right? And so this wonderful capstone of game theory and microeconomics is the first fundamental welfare theorem, which is that any competitive equilibrium leads to this Pareto efficient allocation, which is this wonderful social justice sort of level of statement, right? Except it turns out that these jungle equilibria are also Pareto efficient. I want to emphasize that, right? This is so essentially what you have going on here is everything which general equilibrium theory says in favor of this utopian market system is also true of rule of force. So it's sort of this conundrum, right? It's actually mathematically these are kind of equivalent mechanisms. They lead sort of the same sets of at least general types of outcomes, but one is clearly immoral, with respect to probably any value function that anyone in this room would write down, right? So this is a kind of a ridiculous thing. I like this little palette cleanser to kind of set the tone for what I'm going to talk about next, which is mostly just the dismal science, right? Economics is really the study of institutionalized human suffering, right? It's this, that's all we really ever talk about. Thomas Carlyle was this is in reference. The dismal science quote is in reference to Malthus had just published you guys see the population is growing exponentially. What's going to happen? Back then they believed that GDP couldn't grow. So the pie is going to stay at the same size, but the population is going to go up exponentially, which is, clearly not a good outcome. Anyway, that's not what my talk is about. So this talk, I want to lay out some kind of intertwined thoughts about, one, the rise of mobile devices and these local embedded sensors, the microdata that you can collect off the back of that, and how that's sort of inverting control of economic measurement and reporting in sort of an interesting way. And I'm going to pause at this. This is not only it's not only macroeconomics this is going to affect. It's also local power structures. We're able to document in a structured way the world around us to a degree that we've really never been able to do before. And I think these kind of are two sides of the same coin, really. It's being able to measure the world better at the top level and being able to understand the world better at the lower level they're really due to the same innovation. And kind of fundamentally, at least my kind of guiding principle at premise is you can't fix what you can't measure, right? So if we talk about institutionalized human suffering, how do we fix that? Well, we need to be able to measure it first, right? So kind of starting out kind of in the best case of the world, This is Alan Kruger. He was previously the chief of the Council of Economic Advisors to Obama, talking about economic statistics in the U.S. Right, and he's saying like basically this stuff was developed off the back of World War II, and there's still this like Cold War element to it. Right, we're not making any progress. We don't have any more current. Data's laggy. By the time I need to make a policy decision, the data is already so many months old, and really it's lumpy, right? It's highly aggregated, and it's not available. And try to get like a state level GDP estimate, GDP estimate, right? It's very very tricky. But this is like the best case, right? This is like assuming that like the government isn't shut down. So like last October, like the U.S. CPI release was actually delayed by about a week, because the government wasn't running, right? And then you start looking at other countries, right? Like institutionalized lying about economic statistics in Argentina. Not really sure how that works, but it seems to kind of work. Why does this matter, right? So like this lack of data actually is, I think, like I'm going to posit, has a really profound really profound implications for economic security. And that's where we're going to get into like the institutionalized human suffering, right? So like you guys know the narrative of like the world food crisis, like 2007, 2008, led to like civil unrest in all these African countries. 50% of food consumed in the Middle East and Africa is actually imported, which is like clearly like a huge like structural risk for them. You have like shrinking farmlands, like bad weather, poor water allocation, and we don't really understand how these interdependencies like will like link up and like cause these types of top down it's like a hurricane, right? So a really quick timeline, right? Like starting in January 2007, like in Mexico, there's like the tortilla riots, West Bengal, Russia, Cameroon, Senegal, Haiti, Yemen, Egypt, all having like basically rising food prices. And nobody ever revolted on a full stomach, right? There's a neat study I think it was from out of Queens College last year, who linked food prices and the incidence of low-level violence in Africa. So very like not like massive like like huge riots and like troop movements, but just like low-level violence like break-ins and stuff like that. And they find a pretty strong correlation there. So like this really like this fundamental thing that like causes like local economic insecurity, right? Driven off the back of food prices. To me, what's way more interesting or frightening out of this are the linkage effects, right? So like as these grain prices increased, in China, a large number of the smallholding milk farmers and producers of cattle feed were finding themselves unable to like exist economically, and as a result, they started putting additives like melamine into the feed and the produce in order to boost the measured level of protein. And so what you ended up with was hundreds of thousands of children actually became very sick, and if you look even now, like the milk exports from China are virtually over. There's no exports, right? So you have like executives and officials were arrested, some were executed, companies went bankrupt, like this huge thing, and it was just all this like secondary network effect off the back of that food crisis. So how do we understand these things better, right? Like we've been working a little bit with the UN FAO, it's the Food and Agriculture Organization, to understand like price transmission, which is a really basic factor. You have like vertical transmission, from farmers to wholesalers to retailers. Then you have like horizontal transmission from like how does like it's almost like a weather map, like how do prices fluctuate like across spatially. And this is really isn't enough. Like there's so much more like detail that we need to be able to measure, right? So what can we do about this, right? I think like fundamentally the answer lies in this device. So at the surveillance panel we heard about how all these companies are using your phone to like spy on you, but I think like concordant with that, maybe not contra that. What we're seeing is really more of like an inversion of control, right? So this is like, mobile devices are creating this like, panopticon, right? Like turning the camera back to the local governments, the local economic institutions. giving us the means to document all sorts of, not like the top-down stuff, the really little things, right? The like potholes, like the economic equivalent of potholes, right? Or like police violence, right? Just a couple of examples of this. So this is in Aleppo. It's a company called First Mile Geo. They're pretty forward-thinking crisis mapping platform, and they have engaged field workers in Aleppo, of course, kind of like rebel-controlled areas of the city, and the borders are constantly shifting, and there's checkpoints. The rebels have been destroying bakeries. About 40% have been destroyed at the point I think the survey was done. And so how do you where's the Google map for that? Like why doesn't Google have all this like overlaid on the map, right? It's just not there. Nobody's out there, nobody's able to see this stuff. And these are, this is all off the back of local surveys, field workers with cell phones. Move over to the other side, the side of Africa. In Lagos, there's these guys. It's like a bicycle run. They're called Recyclers. This bicycle dispatched recycling effort. So the local trash pickup in Lagos is pretty atrocious. There's not even really good private companies that do this in a reliable way. And so you can imagine recycling would even more difficult, right? And these guys actually they incent the recycling. It's all the cell phone SMS based thing. And if you contribute enough bottles and cans or whatever, you get points on your phone. You can actually redeem these for. You can redeem them directly over SMS for all sorts of prizes and stuff like that. And then another really interesting example that I've seen the last couple of years is so Intuit, company that makes Quicken, has this platform called Fazil in India, and so in India, roughly 70% of the economy is tied to agriculture, and of course it's one of the largest producers of fruit and vegetables in the world, but due to lack of cold storage, any really cold chain facilities, and just kind of bad transportation infrastructure in general, the post-harvest losses exceed 25%, which is just huge, right? So you have this agriculturally driven economy with massive inefficiency in getting the produce to market, right? And then, so essentially farmers are forced to sell produce immediately after harvest, which results in this kind of these cycles of glut, basically these gluts and then kind of scarcity, food scarcity. So this is this in aggregate you have this structural failure in food security affecting over a billion people, right? So for farmers this low price realization was also a barrier for social mobility, right? And so Fazil was able to actually show they kind of crowdsource the prices, the market prices, and they kind of transmit it out via cell phones, and it actually lets you make these local decisions much more efficiently. And they're showing 20% increases in kind of the clearing price of these various crops. So it's very beneficial to the farmers. So maybe 2 minutes about premise, right? So what if instead of this top-down economic storytelling, we want to invert control of economic measurement, right? So start providing the farmers with the means and incentives to collect local data and then rebuild the aggregate statistics off the back of that. So give the individuals and communities the tools that they need to collaboratively map their local economies, monitor prices, corrupt actors, service quality, stuff like that. Then as the local maps become more complex and dense and stable, we can use them to derive really entirely new types of indicators. We shouldn't be bound to this 1950s notion of inflation, right? There's so many other things that you would want to measure, and there's so many variants of those, taking into account different types of nuance. So Premise, essentially is a mobile platform for, enabling this type of inversion of control. I think I'm going to stop there. I'm getting the the signal, but that's so that's basically it. You can not see all that. And that's our Twitter handle. Feel free to tweet at us or email me any interest. Thanks.
All right, hi everyone. I'm Kevin Coy. I'm the Executive Director of the Geospatial Innovation Facility here at Berkeley at the College of Natural Resources. And what we do is try to support all things geospatial here on campus and beyond, traditional support roles for students, faculty, and staff in training and advising and providing a community and workspace. But we also have a strong application development team. And what we've been doing over the last few years is seeing a rapid shift from the traditional desktop environment that GIS and remote sensing is done on to more data science techniques and approaches to these topics. So our mission at the GIF is to help people better understand the changing world through the analysis and visualization of spatial data. And so we all know there's a lot of really big challenges out there. One of them that's really tremendous is global change and climate change, and it's something although we've been hearing a lot about it for a long time, has really been getting a lot of news in the last few weeks and months. The IPCC just released their 5th assessment report a couple months ago, and what they're saying is planet-wide that climate change isn't something that's just might affect us 100 years from now. It's something that's already affecting us today. And so we need to look at how this has already affected things like agriculture, human health, and water supplies. And just this week, the US released their own assessment. And here's the front page of the New York Times on Wednesday with a really data-rich map showing climate change effects that have been observed here in the US. And so these things are really gaining traction and are obviously of great importance to all of us. Nobody on this planet is going to be untouched by the impacts of climate change. And yet, climate change is actually one of many things that are a real risk to humanity's life support systems in the 21st century. Extinctions, loss of ecosystem diversity, pollution, human population growth, and resource consumption were all identified in this report by a professor here at UC Berkeley, Anthony Barnosky, that was requested by the governor of California. And what he found and what they, with a group of 500 scientists backing, said that we have to start dealing with these environmental problems in a very holistic way. And we need to realize it's understanding how they interact. So traditionally, each of these topics might be observed on their own, but we really need to look at the whole picture and start doing that. And that's what we hope to achieve with some of the projects we're doing at the GIF and here at the university. And I'll share with you a little bit about how we look at the different kinds of data to answer these questions. So let's start with environmental data and ask, what do we know about the Earth itself? And so you've probably seen satellite images like this one. We're looking at the Irrawaddy River Delta in Myanmar in infrared color. So orange is actually green mangrove trees in this case. But what you might not know, if you're not a remote sensing specialist, is that when you zoom down and look at the pixels, those pixels are actually data. And the data even goes beyond what you see with your own eyes. So we're able to see 3 color bands at a time. The data is collected with multiple bands of data in infrared and other areas that our eyes aren't able to see. And we're able to take that information, run it through algorithms, and say things like, okay, from this raw data, what's grass, what's forest, what's water, and classify that image into a land cover map that we can use. And we've been collecting these kinds of data for a long time. From the 70s, we've had Landsat program, which is the most continuous Earth monitoring satellite program. Landsat 8 was released just in 2013, launched, and has continued this really rich wealth of data that we use to look at these kinds of questions. And we have some data sets even going further back from that. And of course, we now have some new paradigms that are really shaking things up and I think are going to make this kind of research much more exciting. You may have read about Planet Labs and Skybox Imaging, both startups here in the Bay Area that are working on microsatellite fleets where they can launch flocks of many satellites that are relatively cheap, inexpensive, and easy to deploy and get great coverage for a greater swath of the Earth and do it in a way that's much more efficient than launching one humongous satellite that if it has a problem, there's no way to retrieve the data from it anymore. We're also seeing paradigm shifts in how do we analyze these data. So again, traditionally, a remote sensing scientist would have to download these images and put them through the algorithms on their desktop. Today, we have some amazing tools. Google themselves have built something called the Earth Engine, which you can look at online, which is tremendous. It's taken the entire library of Landsat imagery and put it into their distributed network that you can run. A research scientist with trusted tester status can use the API to ask huge questions and do analysis at a scale that we would never be able to do otherwise. Next, let's look at climate data. So what's happening in temperature and precipitation and those kinds of topics on the planet. And this is something that the GIF is heavily involved in. And we've built a tool called CalAdapt to help people explore climate change data here in the state of California. So you can visit this site today at cal-adapt.org. It was launched 3 years ago, so it's actually been around for quite some time, but it's still actively being developed by folks in our lab on behalf of the California Energy Commission. So the folks at the CEC and a whole variety of other institutions who produce data here in the state were really interested in getting that information out to a greater number of people. And the California Energy Commission has been really excellent about sponsoring these research projects that have resulted in over 200 peer-reviewed articles on California-specific climate change impacts. And there were dozens of researchers involved in the last decade on these projects. Thousands of data layers have resulted. And previous to CalAdapt, these were locked up in PDFs and written in very specific technical jargon of the scientists that were not very accessible to anyone besides other scientists in their field. So what we are doing is helping to bridge that gap between the wealth of climate change research and data being produced by the scientific community and those who need reliable, easy access to support planning and adaptation. So we have 3 main target audiences for this site: the general public, but the local planners, technicians, and decision makers, and even the scientific community. And that local planners, technicians, and decision makers are really the focus of these efforts, because these are the folks who are making decisions today that really require insight into what's happening in the next dozen to 100 years and lack that information to make really informed decisions without tools like this. So there's a variety of environmental variables available. Most people look at things like temperature, and snowpack here in California obviously is an important one, but there's a lot of other data sets. And one of the technical challenges for our development team was these are really highly temporal data sets. So they each are those raster layers like the images we saw, pixel-based rasters where each pixel is a data variable like a temperature. But because they're highly temporal, there's 150 years of projected data, 12 months a year, 4 models, different scenarios that show what would happen if we get carbon dioxide under control versus business as usual. And so there's many, many, in this case with the monthly data, 230,000 map layers. And these are not the kinds of data traditionally that work themselves out well on a web map to display that kind of level of information. So what we did is, using modern tools like NumPy in this case, create arrays of data that can be queried dynamically to pull out all of the information and dynamically display it in charts and tables. And so all of this is built in an open source architecture, and especially on Django and Postgres, PostGIS. So I'll give you a little bit of a quick tour of the site, where you could go and look at some climate tools that show things about temperature, snowpack, precipitation, sea level rise, wildfire. And I'll just go through 3 quick examples of what these look like. So here on the decadal averages map, you can see what average annual temperature historically has looked like across the state, and then using the slider bar, see what it's projected to look like all the way up through 2099. You could also click anywhere on the map and see a chart plotted that shows the 2 different emission scenarios and what those are projected to look like for any given location in the state. And then for those who need more information, those decision makers, there's more and more options to look at things like the individual months, the temperature lows and highs, instead of all of the averages that you generally get in a report. You could also share this information with a dynamic URL. So if you've got a really custom setup, you can share that exact view with someone else with the link. And you can also see the authoritative institution that produced the data that you're seeing. So in this case, Scripps Institution of Oceanography, and more information about the data sources themselves. So next, let's look at degrees of change map. And in this case, what we're looking at is the end of the century subtracted by the historic temperature to see how many degrees of change you might expect to see. And it's not evenly distributed throughout the state, but it does look kind of even from west to east. However, if I look at a separate month like June, you see that Northern California is projected to see a greater amount of change than Southern California. If I look at November, it's just the opposite. So you're not going to see that kind of detail just looking at the average annuals, but that's really important for someone in agriculture where seasonality is a big issue. So last tool we'll show here is the extreme heat tool, and now we're actually looking at daily temperature data and looking at extreme heat, which is a high health risk. So we calculate the extreme heat day threshold. In this case, we're looking at Merced by looking at the 98th percentile of historic hot days. So these are days 102 degrees is seen in this location, just not very often. And what you see moving into the future is that you're projected to see these thresholds get crossed many more times. Same thing is true for minimum temperature. Nighttime temperatures are also projected to increase greatly. And you could even break this down to look at the timing. So here we show April 1st through October 31st in the y-axis. And each day that crosses that threshold gets a dot. So you see that these extreme heat days are projected to start happening earlier and later in the season than they ever had before. And this is all very locally relevant. So these algorithms are able to show that the temperatures are quite different. In the Bay Area, an extreme heat day in Berkeley is actually 83 degrees. So that's comical to most, but those of us who live here know that 83 degrees is actually pretty hot in Berkeley. But just in March, we were really excited to participate in the White House Climate Data Initiative launch. And it's really exciting to see that people are taking these topics and data sets really seriously and looking at how best we can distribute them to other regions in the country and the world. So let's take a step now and look at biodiversity data. We've looked at the Earth itself, but what about these things that are on the Earth? And what do we know about life on the Earth? And so not a lot. 86% of species are still unknown to science, have not been cataloged. And there are still huge efforts just to do just that, find what species are out there. And we're working on a project called the Berkeley Ecoinformatics engine, or Holos here, to create ways for people not only to discover this information and visualize them and analyze them in ways that hasn't really been possible in a holistic way. So I'll go through a few different of the data sets that we're including in this engine. One of the primary data sets is geolocated specimen. And spatial data comes into play here because no matter how disparate the data sets are, they almost always have a place and a time that they were collected or where they occurred. And so we can use that to match them up. So just here on this campus in the museum system, we have nearly 16 million physical specimens in jars and drawers and all over the place that are studied by scientists. And these are being digitized by lots of folks to get more information out of them. And while they digitize them, they actually make a point on the map where they were found. Easier to do in the modern ones when we have GPS, but 100-year-old data, sometimes that's harder to do. There's a lot more that needs to be done on this digitization, and you actually could help in some of these crowdsourcing efforts. So the Essig Museum has something called CalBug that you can go to. It's a citizen science project, and you could look at a picture like this where they've taken the insect off of the pin and the small labels aside them, and you can digitize what you see on the labels so they have them in the database. I actually just checked, and there are over 500,000 submissions in the last year on this tool. Another really amazing citizen science tool is a product that came right out of a master's project right here in the iSchool by Kenichi Ueda, and it's called iNaturalist. And if you're a person who enjoys hiking and taking pictures of things you find in nature, whether you know what they are or not, this is the tool for you. It allows you to record what you see, share that with others, and even get feedback on what you might think it might be and whether you were right or not. And so it's a really amazing tool that also is seeing hundreds of thousands of observations. And so beyond just the citizen science components, we as scientists can actually use this information ourselves as well. So when we have those two things, the Earth data and the species data, we could do things like look at suitability maps. We can map out, for in this case, an example, a Lyme disease vector showing in Europe where you might expect to see it based on what we know that they like to live in terms of climatic suitability. And so this is using current data, but we have the climate change projection data into the future too. So if we run the same analysis looking at data from 2080, what we see that this Lyme disease vector might be able to occupy a much larger area than ever originally expected. So these are all really important issues, and not just for the animals themselves, but even for us. More data that comes out of the university. We have a whole series of field stations all around the state that have been collecting data for years, including from sensors. We have 15,000 jars of soil sitting in Richmond in a warehouse that no one had looked at in decades. We've had teams of undergrads digitize everything on these labels so that we can actually use this information and get more information out of it. Pollen core data shows us really deep time series, so 150,000 years of evidence of what species have been located here in California can be seen in a pollen core. And what you see in this chart in green are tree species where their pollen occurs throughout the entire 150,000 year time series, and in red are the species that only start to occur after Native Americans and Europeans arrive. There were vegetation surveys done by USGS scientists in the 1920s through 40s, and they painstakingly drew hand-drawn maps all across the state of the vegetation, and UC Davis scientists have digitized these into geospatial formats that now allow us to use these in digital analysis. And the scientists that drew those maps actually took 3,000 photos while they were out there and had the foresight to draw a point on the map where they took the photos. So we now have all these photographs georeferenced and available. We're building a tool now which will allow you to revisit and reshoot these so we don't only have quantitative measurements of change, but qualitative. We have lots of base layers, like we've said, between climate change data and land cover, land use. And the whole idea is to put this into a RESTful API so that it's available not only to us, for us to build our own tools, but for external developers to build tools around these, and also for research experts to start to use tools like R to tap straight into the data set themselves without even having to mess with our browser. And again, this is all built on an open source web stack, much like the other. And it's available now at a site called ecoengine.berkeley.edu, where you could go in, browse the API, and get the information out in GeoJSON and other formats. And so just a couple of quick examples of how you might use this. Here's D3 showing the sensors, the visualization. And now we'll look at solar radiation in one of our field reserves. And so it's really trivial to produce some code to show some really interesting things. And now we'll be able to share that code with others so that they can take the same information, build upon it, and show more interesting things themselves. Here's species checklist data. This arrived to us in an Excel spreadsheet. Now we have it in a format that is able to show some taxonomy and give more information than previously existed. Here's a quick view of what that photo resurvey tool will look like. So you'll be able to browse around the state, see where photos were taken from the Wieslander surveys, and go in and reshoot them yourselves so that, and upload them to our data set so that you can look at the change right there in the website. ROpenSci is an amazing project by a postdoc here at Berkeley, Karthik Ram, and it allows for R to plug directly into research APIs like the Ecoengine. So suddenly with 2 lines of code, you can build a map like this. And it's really powerful and amazing, and I highly encourage you, if you're into R, to check out ROpenSci. And lastly, now that we're on our way with the API, we're going to build a nice front end to this site, second, where anyone will be able to search and explore the tools and the data. So just to close out on a note of open science and data, it's been really thrilling to learn about what's happening in all the fields here, and I'm really excited to see how that can tie back to the kinds of work that we do. So it's really great to see that research and discovery no longer has to be limited to scientists, but really anybody can now tap into some of these open data resources and produce engaging interactive outputs. And of course, we're really interested to work with all of you here, so I look forward to chatting more, and thank you for your time.
I'm going to call something of an audible on this talk. and sort of make it the mean of 2 different talks. So I'm Mike Conover. I'm a data scientist at LinkedIn, and on my team we use the behavior and relationships of hundreds of millions of people to help connect the world's professionals to make them more productive and successful. Can you hear me?
Yeah.
We're good?
It says your mic's not on.
It sounds like I'm mic'd.
You're probably picking up that. Where's the...
Yeah. So, right, the visual faculties. You hold in your mind the image of a flock of birds or a very large school of fish, and the way that they move with a sense of collective purpose. So my background is in a field called complex systems analysis, and these 2 systems are very characteristic of complexity, which is characterized by behavior in the aggregate, which is not described by the rules governing the interactions at the local level. And so in each of these systems, we see immediately and can apprehend immediately macroscopic structure that is only easily apprehended by the visual faculties. You see in the fractal structure of the veins in this leaf a branching pattern that could surely be described with a set of summary statistics that would fail to capture somehow the complexity of the system itself. And when we interact with technology, we create this digital trace data that allows us to study human systems at a global scale in this faraway sense, or from this faraway perspective, or in the way that we study the cell. You can take something that unfolds over many months or years at a scale of hundreds or thousands of miles and begin to study it in a very tractable way. And it's through the use of visualization technologies that we can begin to hold these things in our hands. And so here we have a map of traffic flows through Lisbon, Portugal. And this is using data taken off of GPS meters in taxi cabs. And the breadth of each line corresponds to the volume of traffic flow along that thoroughfare. And its color corresponds to the speed with which that traffic moves. In the bottom right here, this is on the sea, you can see the old city. And it's very congested. And then you have these major modern urban thoroughfares. This kind of intuition, I love the work that we just saw because it captures this so succinctly. In these interactive videos he just showed, you can touch the data in a way that for urban planning, point estimates coming off of intersections would tell you so little about how traffic moves through a city. But because we now have a very cheap way to instrument a phenomenon that has historically been very expensive to measure, we can make better planning decisions. And so I think there are a couple different examples of this that are very exciting recently, and I think Planet Labs and Skybox are 2 great examples. I mean, think about, these are satellite systems where you bid on imaging time. And if you need a photo in 3 months, that's cheaper than if you need a photo in the next 24 hours. And this sort of follows the cloud computing model, where I don't need a satellite personally. I just need a little bit of a satellite. And this becomes very powerful when you think about getting a real-time API on the surface of the Earth into the hands of NGOs. Think about if we had images coming off the Ukrainian border right now. How does that change the political calculus? And I mean, I use as an example, studying the Amazon rainforest and climate change. You have to hack with a machete, historically, through the jungle to get these numbers. And now these systems are making it vanishingly easy to measure these signals that have been very expensive to collect historically. And that, I think, is the structural change that characterizes this revolution that we're seeing with these large-scale compute applications. And this follows the arc of information over the last 400 and 500 years. I mean, you think about the innovation that was the printing press. This made it the marginal cost of producing new information much lower. But paper and books are still a rival good. You and I can't read the same book at the same time, or it's very difficult. The rise of broadcast media takes us from a rival information economy to one in which the marginal cost of an additional consumer is effectively zero. One more radio listening to a broadcast doesn't affect the quality of the signal. That regime, and you can think about these different, you think about the way that the network structure of information flows. These are changes in the phase or the state of these networks in the way that water and ice are the same fundamental components but operating in fundamentally different regimes. We go from a rival economy to a broadcast economy, which has a hub and spoke-like structure, to the networked information economy where you no longer have to have access to capital to produce information, and now everyone is a producer and a consumer. And this is the rise of low-cost computing infrastructure. The next structural shift that we will begin to see, and I think Joe's, it's funny, I use premise as an example in this talk. Joe's work is right on the nose with this, where instead of everyone having a computer, everything is a computer, and you're beginning to be able to capture these signals at a very local level, very cheaply, that give you high-resolution digital trace data on the world as it evolves in real time. And so this, as the marginal cost of capturing new signals that are highly correlated with things that are expensive to measure approaches zero, we're going to, I mean, this is what we're seeing, is the ability to measure these kinds of systems with very high fidelity. So with respect to information visualization, so this is how you sort of see this is the composite of two different talks. Now touching again on information visualization, I think that this is a statistical enterprise and it is a quantitative enterprise, but it is so vital that we make it easy for everyone to be as close. You talk about computing, you want to be close to the metal. Here, you want people to be close to the data. I work with product managers who are very savvy but are maybe non-technical, and to the extent that we can get them with eyes on the data and able to interact and iterate on hypotheses, we're much more effective. So you think about the structure of your software. I think of software as a very geometric entity, and the way that lists have dimension. I have a friend on the Google crawl team who asks that you imagine the structure of your software as the physical manifestation of your software is this giant artifact with feed belts and pulleys and levers, like a watch. The systems that we study when we're talking about geospatial systems or societal scale systems have this structure too, and these nonlinear relationships, and you try to get a mental model for how these things interact. And to the extent that you can visualize these processes, you are able to really refine your model beyond looking at lists of numbers. You have much more realistic mental models when visualization is part of your workflow at an innate level. And I think that this is directly tied to how effective you are at either scientific enterprise or predictive modeling. Because I want to get to the panel, I'm going to skip the rest of this. One of the things that I think is very important when you wire visualization into your work at a genetic level is that it makes it very easy to generate novel hypotheses about how the world works. So this is a project I worked on in grad school called Truthy, which was a system designed to detect propaganda campaigns. And you have a system monitoring a 10% sample of the Twitter feed. And for every meme that we observe, typically hashtags or usernames or snippets of text, we would visualize the diffusion network, where each point is a person and a line is drawn between them if they interact, either in orange if I mention you, or in blue if we retweet one another. We also visualize these time series, and this becomes an interface onto this large-scale data stream that allows anybody to interrogate a feed. So of course we generate summary statistics, but there's this notion that with many eyes all bugs are shallow. The more people who are looking at these memes, the easier it is to tell if one of them is a propaganda campaign, where you have many different accounts controlled by a central agent, and these accounts interact with one another. They create the appearance of consensus. For example, don't you agree about the gun control policy? isn't this what we think? Yeah, and they start to talk to one another. And so when you visualize these networks, I mean, our problem is one of predictive modeling. Hypotheses and intuitions jump out of the data, and you begin to see how this network on the right, which is a promotion for a nightclub, is very different from the organic structure of the conversation surrounding the White House account. This is messy. It has a scale-free distribution, and this is very regular. You have these fans where one account mentions many, many other accounts, and then they all pretend to talk to one another. And these are bots pretending to engage in conversation. And so this suggests features that might be discriminative for the problem of distinguishing these two classes of communication. But in the course of undertaking this research enterprise, another aspect of this discourse emerged, which is this biclustered structure in many of these networks. So we're focusing on political communication. And we see that there are two communities in many of these memes, two communities of individuals who are preferentially retweeting one another and who are engaging across the divide in the form of mentions. Aggregating across all of these different memes, the partisan structure of American political communication emerges from the data. This is so telling and dramatic and immediately tells the story of the echo chamber and gives us an opportunity to bring in research from media and political theory and begin to try to understand how social media shapes at a structural level the political discourse. And in addition, we now have a way to predict a person's political affiliation, which gives us this ability to instrument at scale the kinds of issues that left-leaning individuals who have talked about gun control are concerned with. Or if we use named entity recognition, the people that are on the ascendancy among the right. This is an example of how machine learning technologies and data processing infrastructure make it simpler to measure phenomena that have historically been very, very expensive. And to the extent that we invest in infrastructure and policy that supports the ability to build out these systems and then get the data. I mean, my thesis was built on the back of the Twitter garden hose. And so we were talking out in the lobby about how you make this vital social signal. I mean, what can you, I work at LinkedIn, and I think a lot about how you could inform economic policy with our high resolution perspective on the temporally evolving structure of the global economy. These are important issues, and I think to the extent that you build systems that allow the public to interact with your data, and also allow researchers who may be savvy but non-technical to interact with the data, I think that we pull a lot of friction out of these systems. And I think that there's a lot of potential in both of the topics that we've just touched on, and I look forward to the panel.
That was fantastic. Thank you. You know, there's this, do I turn this on or does it come on?
To the left. You're live.
I'm live. Okay. There's this term I use in my class, and I want to bring it up here to explore what I think is a useful issue. I say we're living in a barbell world. You know, it's super powerful controlling institutions, super empowered individuals, right? There's never been more control. There's never been more freedom. There's never been more access to information. There's never been more difficulty sorting out the truth. And you got this like continual series of extremes. And when you're in that kind of a world, in some ways, I think the signal really is your language is broken. You don't have good ways to talk about things anymore because you sort of lost a middle distance. And it really illustrates some of the intellectual and social challenges that are before us as this becomes a sort of pervasive way of operating a complex world. And with that in mind, I just wanted to sort of think a little bit about what do you think are the data forces that will disrupt what we've identified as a bad thing that we don't want to have happen, which is excessive top-down control in this world? How does that sort of start to happen? And what is the better model that might take its place? And we'll play jump ball, because nobody's got an answer for that, absolutely.
I mean, am I on? I think there's, a huge factor in that really is, I don't know if you've read, so I finished Darren Acemoglu's book from a couple years ago, kind of about how political institutions actually shape economic incentives.
Right.
And so you have these countries where essentially like you can drop as much technology as you want on farmers, but they won't use it because if they do end up producing more, it's just going to get stolen by whoever's kind of higher up in the power chain, right? So there's kind of this this disconnect between infrastructure building and the actual economic incentives themselves. Mm-hmm. That to me is like the fundamental like it's those local decision points. That's where shaping development and fixing if you're taking moving control from one side of the barbell to the other. Mm-hmm. It's like how do you enable the people at the bottom there to actually kind of react, right?
I mean, we're building, historically, we are making these very locally constrained decisions in the absence of good information. Mm-hmm. And I think the job search is similar in many ways to a person trying to sell their agricultural goods. And you were, I think someone told me about an example where there are people who perform an arbitrage service by going to different farmers and saying, I will take your goods to market, but you don't have good information on how much they're going for at market. And so you're going to have to trust me, and you don't know when I'm going to come back. To the extent that you can get, these data pipelines process information at scale and see these structural features in the economy, in the job market, and then can deliver at a local level that insight, that synthesis, to hundreds of millions of people. And so as you can get farmers better information about how the market is handling itself 8 hours away, you pull this friction out, just a very small amount of friction out of hundreds of millions and billions of interactions. So that's how this scales up. It's many, many small changes at the local level, aggregating up at a societal level.
I think something too we're seeing with the climate data, when we first built this site 3 years ago, there was a lot of concern on the part of the climatologists who were producing the data that this was too much information for non-scientists to have their hands on, and
right.
They were going to translate it inappropriately and use it in inappropriate ways, and there was a real concern. And so what we found, though, is that having power and information was a better alternative to no information, and that we have people in local communities now who might be building a dam that has to last for more than 50 years. And if they don't have information, even if it is uncertain about what that landscape might look like 50 years from now, then what are they going to be able to do with that? And with, at least with our work, what we've found is really positive reactions and an understanding from local people who may not be data scientists themselves, but have an understanding that, yes, there is uncertainty in data. They understand that they see the weather data and that it might be wrong tomorrow, even though they said it was going to rain, it didn't. So sure, we know that there's uncertainty in long-term climate data, but that the trends are there and that these are things we need to think about.
Mm-hmm. I wasn't actually thinking about strengthening one end of the barbell as much as trying to get things back to a healthy middle, because what you just illustrated, I think, was evident in the surveillance panel as well, which is all three institutions, corporations, governments, and academia, are not just troubled, but really kind of undermined by what's going on. As much as they seem like controlling forces, governments their job was controlling borders in some ways, right? You know, you had a national currency and then another currency happened at the other border. They had an army that projected violence to the border, over it where they could or back, you know. And you had post and telecommunications, which had stamps, like and international stamps versus national stamps. It was always focused about the border. And you had companies that were selling products without a real sense of what that would mean in a larger situation, right? Like, the Krispy Kreme is really good for you. I'm not worried about your weight, but now that's kind of being undermined as well. And academia, likewise, you know, had this canonical view of if that information about heat got into the wrong hands, it might not be understood the way we're understanding it. That's bad. I think all of those forces are actually, what you're saying is all of those forces are very troubled by that as well. That's kind of a crisis for all of them, and they're going to have to get used to that. But people want those things, don't they?
This is so typical of like professionalization. Like where, you know, Vinod Khosla talks about like doctors being irrelevant in 10, 15 years. And it's like the art of medicine is a more appropriate term. And I'm inclined to agree that a lot of these prescriptions are maybe contraindicated when you really take a holistic view. And so
I'm kind of a fan of the FDA and, like, you know, drug safety.
There are a lot of issues here, but I think the point I'm trying to make is that this idea that there is any one organization or entity that should have the exclusive domain over data, that's sort of like a self-protecting act.
Yeah.
And so, you know, the idea that you wouldn't know what to do with this weather data, it's like, you know, machine learning has this character where it's like, well, you can really go off the rails with the statistics. It's like,
right.
I disagree. I think machine learning as a service in the hands of as many people as possible with like reasonable statistical rails on the thing is much better. And so these institutions should be troubled.
But that also leads you to the WikiLeaks dilemma. You know, they released all of this information that was private, but it wasn't well vetted, and some guys got whacked because the information was shared broadly. I'm not sure you can universalize that point.
I mean, there's definitely, you know, I think there's definitely two sides to the open information debate, right? That's a really good point there. I sort of like personally always, I guess I always wonder when we get engaged in these types of conversations, like, you know, we're talking about kind of unprecedented ability, you know, due to like, you know, better information infrastructure, unprecedented ability to disseminate, collect and disseminate information, right? So is that actually translating, like in a historical context, to like unprecedented volatility? Like, is this something on par with, you know, any major technological advance, you know, anytime in the previous eras, right? I mean, you have like examples like Industrial Revolution, where like, you know, social mobility increased suddenly, like, you know, just you know, multiplicatively, right? And that just created all this disruption off the back of it. Are we seeing something like of that flavor? Is it even bigger than that?
There's a good chance, yeah, don't you think?
I mean, like living in it, it's hard for me to like turn the lens back.
Yeah, I mean, we're swimming in it, so it's hard to know what it is. I suppose that's a terrible thing to say, but you know what I mean. You know, Bitcoin is a good example of that. A currency that has no state,
right,
and appears to have some kind of lasting, you know, embedded quality. We are heading into some sort of post-nationalist thing here that we don't really understand.
No, I'm really curious at that point, right? What is the function of government now, right? Like what things are still relevant given all the stuff that we can do in a disaggregated like manner, right? Like currency regulation, maybe.
But you know, like
that currency regulation is data cleanliness. But go ahead.
Well, no, but it's interesting, right? Like self-regulating systems do not always attain like satisfying non-brutal equilibria, right? And so I think policy is still the domain of government. You know, we're in this situation where it's like, well, in a completely open and, you know, transparent society, we may have negative outcomes. And so I think that there is a role for regulation, even if stateness, I mean, we see this with like immigrant visas, where it's like, you know, the idea of state becomes problematic for, you know, intellectual productivity. But I think regulation is never going to be irrelevant because systems can become degenerate so easily.
Were you at LinkedIn when they did the study for the U.S. military?
I wasn't.
They did some work. This didn't get published because the client wasn't super happy about it, but they found one of the great predictors of homelessness was military service, because you were removed from your context. Everybody else between the ages of sort of 18 and 22 had gotten started in life. You lost your high school friends, you didn't have a social network, and you were put back in society, usually in a different place. And so you lost that immediate web of a guy who could give you a couch to sleep on for a month while you were getting things together. They weren't really happy with that outcome, rather with that information. And like, I think they did some stuff about sort of job training and awareness around this, but it wasn't broadly surfaced. And I suspect there are many such instances where, I'm not picking on LinkedIn here, I'm just talking about like,
how to
on a general basis. There's a lot of implications here that you can call it data, but it's so inherently political.
Yeah. But this, I mean, like, that's just, you can't be an ostrich about it. Like, let's make informed policy decisions on the back of like strong, statistically rigorous data.
What's the strong thing here? To control the analysis or to control the data sourcing?
Guys.
Well, I mean, I feel like having multiple people doing different analyses with the same data, the best will rise to the top. And that, when you have the same data sets being made available openly to a number of organizations and people, and multiple people using those same data sets, you're inevitably, hopefully, going to have some that do show more rigor than others. And that's what the scientific process is all about.
There's an interesting example. I don't know if you probably saw this from a few months back. There's a researcher at Columbia. Her name is Emi Nakamura. She was digging into Chinese GDP and price data, and found essentially it's really hard to find direct evidence of like government manipulation of a statistic, especially at the level that it is manipulated in China, which is. Essentially, they don't release very important blocks of data, like component weights on CPI, for example. Mm-hmm. And so what she did was actually but she actually went. But they're still like a functioning government. They still have to create the data. They still have to use it, right? Like you can't both lie externally and lie.
Right. If they don't show up with something, people will kind of.
So she actually dug into the province level data. And they backed out this analysis based on angle curves to show that, like, essentially the high-level statistics, the ones that are like moving the markets, are smoothed in certain ways. They're not like really wrong. They're just like smoothed out. It's a really fascinating analysis. Like, it's like what degree can a government actually manipulate?
God, that's so Confucian. The point of the data is to, it does also have a function of avoiding social disruption. Yeah. We can get there, but let's not be abrupt.
Exactly.
I spent 6 years in Japan, and I can tell you the Ministry of Finance does this all the time.
Right. I thought it's a brilliant example of like basically a government, like if they want to enact a policy change, they want to do it in a way that's socially responsible. And so, maybe, not, hedging a little bit about the data is one way to do that.
Mm-hmm. Well, how do you see this affecting all of these institutions, government, academia? People in this room are seeking, pursuing, or already have careers in all three of those. How do you see this shaping them? And do you see some sort of fourth or fifth kind of institution arising out of the practice of data science? That's a big question, yeah, I know. And it's 5:15, but what the hell?
Well, so I did some work on, open data initiatives for government, I think are amazing. And San Francisco has a great open data portal. And I did some work on health inspection data and looking by area, like which kinds of restaurants, and this is that sort of like combinatorial excitement of data where you can take this health inspection data and then, for example, combine it with Yelp data, which has this rich sort of metadata, and you can look at like by restaurant type. Mm-hmm. Which places are the most unclean and things like this. It's interesting. And in addition, you can then back out a model from that helps you understand, based on attributes about the restaurant, for a restaurant that is opening new, you can predict a little bit about what its health inspection score is going to be like. Mm-hmm. And we have a government organization that is very resource constrained. They visit most of these restaurants at most twice a year. And a very serious, public health issue. Unsafe meat is very dangerous.
Yeah.
And so it's like this stack ranking. How do we prioritize which restaurants we visit and how often? And there's a lot of inefficiency because these heuristic decisions are being made by people in government who have access to limited information. And I think that in terms of the effective function of government, we're going to see much more efficient policy decisions being made. And I think the former CTO for the Obama campaign is now University of Chicago, working on identifying students who are at risk of dropping out of high school. And this is the same kind of problem, that like we will begin to see government using predictive modeling to maximize the impact and leverage of increasingly limited resources as we see this tightening of budgets. And I think that unequivocally is a positive development for government.
Yeah.
Yeah, I mean, I agree that all of these are going to be huge changes for academia, for government, for everyone. But just within my own short career, I've seen tremendous advancements because of it. And to be able to see what we can now accomplish in biology and environmental science that we couldn't have dreamed of 10 years ago, and to think about what the next 10 years has in store based on the confluence of all of these technology techniques and the open science and open data is just thrilling. So whether that means it's another institution.
Have you seen academic behavior change?
Absolutely. I mean, it's something still that people talk about. In terms of open data for a scientist here, there's often a concern that I've collected this data and I need to hold on to it until my publication is out before I let anyone else see the data.
Yeah.
But yet now that people do need data from multiple sources just to have their own publication, you're starting to see more openness to sharing and more of the fact that it's your own novel research that is the important part.
The
not just
evolution
the data.
of archives has been kind of interesting that way.
When you think about like the computational social science, was sort of in vogue for a time, and I think it's just going to become social science. In the same way that survey methodologies are troubled by biases in the surveys and in respondents, like all instrumentations of the world have biases that are inherent to them. But we see academics just realizing that we have a way to measure the world that was not available 5 years ago, and this explosion of analyses that come out of that. And so there just aren't enough grad students.
Okay, so that's government and academia. Do you see ways in which this will change corporate behavior or corporate structures?
No, I think not. I think they're I'm sorry.
Joe was going
I'm kidding.
Joe's
No,
going
it's a good question. I mean, I haven't seen a lot of, there's been a lot of organizational study like at that level, right? There's just you get kind of all the problems of like kind of observation bias, right? When you're looking at like organizational structures and survivorship bias and whatever. There's really not a lot. You can't really set up an A/B test over two companies, right? I mean,
Right.
Some might argue that Silicon Valley is that, but it's actually not the case at all. So I think we get better at certain things, like internal corporate processes. You see the stuff coming out of Google, for example, about interviewing. Right? They did this kind of massive longitudinal study on what things, what questions or like what things did we ask, or what traits did the candidates have that predicted their success at Google? And it turned out that there's really nothing in the interview at all, other than was it a direct reference, or was it was it they sourced externally, right?
Right.
So that's really kind of sad, but that level of like knowing that sort of stuff is I think really, really amazing, and really enables a whole other level of like. Improving the efficiency of organizations.
Well, on the VC panel yesterday, we were talking about how the CEO of Target had to resign. And it isn't so much over the financial loss, because they have a bad quarter and they can lose like that. It's over the loss of face. And as somebody in the fraud detection side of a big security company said to me, they're all making enough money. They're all rich. So their reputations start to matter even more to them. And that's a really interesting implication of this potentially, because it may kind of revert to Adam Smith in Wealth of Nations. He talks about the invisible hand, and it's kind of self-correcting. But he also said that bad actors would be hindered from bad actions for fear of public shaming. And that's been detached in the post-war economy because you could, do terrible things around the world and then just get the train back to Greenwich and nobody really knew it was you. And the visibility is back in there maybe. And that reputational dimension that people crave as much as money.
Do you know like the stuff on there's work on like favor economies are really big in developing world, especially like rural India, right? Where I do you a favor and I expect some I expect that to be repaid at some point, but the way that it's accounted for is in reputation. Mm-hmm. So there's some neat research I just saw came out of University of Washington on like looking at do the structure of these social networks actually impact like sort of the efficiency of the favor economy,
Cool.
to kind of put a word on it.
I want to take some questions from the audience, but I'd like one of you to figure out how to quantify awe so that we can turn that into a good. Do we have questions from the audience for our panelists? Yes, sir.
Yeah.
I think so.
So just wondering in terms of, when we have large data sets and we're putting them through black box systems, and then going back to things like this restaurant question, like it's easy to see how that could turn into like a politically correct question where, if it turned out that Scottish restaurants were
Say, for example.
and were particularly dirty or like whatever. I always choose Scottish because that's where I'm from. So I don't want to pick on somebody else. But like how do we deal with that going forward as this aspect of prejudice, racism, sexism is still something that's very concern worthy. Yet at the same time, we're dealing with these big data sets where we're not necessarily looking for that, but it might so happen that the answer we find hits on one of those stereotypes.
Is prejudice okay if it's data-driven prejudice?
Well, is it still prejudice if it's data-driven?
Exactly.
That
That's a
is
really
really
hard
the question. And
Exactly.
it's awful. That's an awful, hard question.
If you find there's prejudice, like, is it our responsibility to then step away from that answer to the requirement, or?
And like the concern, I think, that I have is this idea that you could, like, a person who has prejudices can wash their hands and say, oh no, but the data you see.
Yeah, see?
And my treatment of this data set suggests that gay people should not get married. And it's just like, you're using this as a platform for your biases. And you're hiding behind this wall of statistics.
That
And that's
has happened
very
before.
insidious. You make an excellent point.
Yeah. I think it wasn't so much a point as a question, what do you do about that? Not to make it harder for you, but.
Statistics education for public policymakers.
Right.
I think to the extent that is a
People need to
highly
be able to
leveraged
read
move.
numbers, yeah.
Yeah, that's where I would start.
Yeah, but statistics have to become an accepted part of conversation in politics. Yeah.
Coming back to the example I gave of the scientists being nervous about climate data being out was for that reason. So somebody might not just take the data and do something wrong with it by accident, but purposely come up with another agenda and use our own data against us, but they're using it incorrectly. And how would anybody who doesn't have that scientific background know that they even have done that? And I think that is a legitimate concern, but in the end, just that the benefits outweigh the risks, and that having that kind of information out there, hopefully again would be more socially filtered by people to say, well, that's wrong of you for thinking that, and here's why I think so.
And to the this is why data transparency is so key, right? It's like, well, okay, your analysis says that nobody should eat in Scottish restaurants. I'd like to take a look at the data. And I've got 10,000 friends who are also curious and have some free time. And it becomes much harder to try to slide one by.
But the other part of your question was, what if the data, every time you munge it, just comes out it's true? Right. Every time, every angle I come up with this, I get Scottish people ask really hard questions. And that's just like a thing that's true no matter what my political bias. Then what do? I think categories better start disappearing and we see each other as individuals. I don't really know how else to answer that.
And I think, they're also like, there aren't a lot of women in tech, therefore women aren't very good at tech. It's like these, you have to be so delicate with how you interpret the data. And I don't know what the answer, I obviously don't know what the answer is.
That's kind of what I was going to say about the Scottish restaurants, right? Is it's not enough to know that Scottish restaurants are dirtier or whatever. You need to understand the why, right? Because the why part of that question, the causal part, is the thing that you can maybe apply leverage to and improve. Right.
Right.
Okay. Other questions?
That was a good one.
What's your favorite
Yes, sir.
color?
Hi, I'm an epidemiologist, work for a medical school, Toro University here in the Bay Area. I would like to hear from you a little bit more about measurement and actionable data. For example, in epidemiology, we know that if we measure the health of the population using mortality, or if we get disability-adjusted life years or quality of life or a Gini index, we have 4 different types of actions. For my medical school, I also analyze the data for students who struggle. A common cause is heartbreak or grief, family loss. So I think we already know a lot of things that may not be amenable to being solved with more data. And regarding statistics, with so large amounts of data, who needs statistics? Everything will be statistically significant, even if you chastise the data with Bonferroni, and basically you have a census. Could you comment on that, please?
Yeah, I think, in economics, this tends to get brought up as what does it mean to optimize GDP? Is GDP a number that we want to? Do you want to gamify that? Is that a good thing? Maybe are there other things we should be measuring that would that we can all agree upon that would be a better aggregate metric? There's a suggestion of gross national happiness, right? Has been bandied about. A little bit harder to measure. It's sensitive to a lot of other things that GDP isn't, but maybe it's a better metric. And I think it is a really good point. Being able to measure better also entails this well, now I want to optimize, right? And now I actually want, not only do I want to measure it, but I want to figure out how to improve it, right? I think it's definitely incumbent on, and this goes back to the discussion about the kind of morality of data, but this really gets back to the point about you need to understand how. What are all the kind of implicit in optimizing that number? What are all the secondary and tertiary effects? Right? There's all this stuff that's going to happen that you may not be able to predict off the back of it. So you just have to kind of be open to that, right? I don't know. Do you guys have?
Inherently, there's a lot of complexity in the data, and some of what you're saying, I think, is that you might be looking for answers to questions you already know the answer to. But for the types of things we're looking at, I think there is so much complexity, especially in life, and we know it's there, and we know that there are food webs, for instance, but we know remarkably little about what even eats what, and this is the kind of information that is going to be vital to our survival if we have decreasing resources and many more people here on the planet. And so I just think the more you do know about those things, the better off you'll be. And I'm sure the same must be true in epidemiology. And tangentially, working with health scientists in geospatial has been interesting for me, because in the environmental realm, we do have the benefit that sensors can give us a whole lot of information about what the forests look like and what's happening in the climate. But as soon as we want to find out about the health of a rural village, you have to start knocking on doors and seeing what's inside and doing the surveys, and that's a lot harder to come by that information. But I think the more we are able to start instrumenting and having more citizen input to that, the better those sources of information will be for everyone, including the health fields.
I think there is, and you raise a point about the secondary effects. I think there's a significant and interesting shortcoming in the science, which, I mean, you imagine like the time before Newton and Leibniz came to, brought the calculus into play. It must have been very confusing, and people must have understood that curves were important and were just left mute as to how to handle them. I think complexity and like nonlinear long-range correlations in these systems, and epidemiology is very characterized by, viruses spread differently on scale-free networks, for example. We are now in this, we have the capacity to instrument multidimensional aspects of complex systems, but we're still optimizing for single statistics like unemployment and inflation as though it's a lever.
Right.
And so we run the risk of fetishizing single statistics if in systems we know have complex nonlinear effects.
Okay. Well, thank you very much. I think Anna wants to say a few closing words.